see, all these questions are from question paper only again. Huh? Here, the number of chemically non-equivalent proton expected in H1 spectrum of these two pinene. Okay, so this type of bridged systems are present in pinene type of compound. This type of compounds are available, or stereochemistry is well defined in the Eli book, Eli of stereochemistry. So it is there. Now, what is the question? Chemically non-equivalent. And if you see the multiple choice questions or these multiple choices, like 6 and 7, they are closely related. So it will be like very, very difficult if you don't know how to solve this type of question. Again, number of signal observed in H1 NMR and proton decoupled C13. So the H1 as well as C13 you have to predict from this given structure. And again, number of signal observed in para-2-lead. This para-2-aldehyde is okay. And 4-mark question, that the correct match between the following, that para-xylene or the structure names are given or even structures are given, and you have to correlate between these two columns. For example, if you know that there will be like only one structure or only one signal is there, so you will be easy. It will be very, very easy to join this among themselves. So such type of questions are there. For this purpose, what you have to do, you should know the name as well as the structure. For example, there are every time they are asking a question when two age groups they are like ortho to each other on the benzene ring. Do you know the name of that compound? When two OH groups, phenolic OH groups, they are ortho to each other on benzene. Name of the compound. Or if two OHs they are meta to each other. What is the name of that compound? Or the last third compound, if two OH group they are present at para position to each other on benzene ring. So these three compounds are, their names are like this. First is catechol, then resorcinol, and third is like a hydroquinone type of system. Three. This question is there in the CSIR exam. Only the name of these three compounds given, and they ask about their H1 NMR or C13 NMR signal. See, for example, here the number of chemically non-equivalent proton. So you have to, or you should know that how many type of compound peaks are will be there in the given compound. Okay, see how to go for this. First and most important trick is there, whether symmetry is available in the given structure or not. The symmetry of this compound, whether it is symmetric. What do you think? Whether it is symmetrical or unsymmetrical?
Asymmetrical नहीं येणार.
No, it's not symmetrical, right? Why? Because there is a double bond present on one side of compound, but there is a no double bond here. So this will be like an unsymmetrical compound. So if symmetrical compounds are there, they will give like a half of their signal. For example, C. Here, these two pinene, what we have to count? H1 NMR. So how many hydrogens are there? Non-equivalent hydrogen or chemically non-equivalent protons. So this will be like one, there will be one signal, one proton. Then we will go clockwise. One, here there will be hydrogen, two, three, four, then five, then six. Okay, and these two are like same. These two are present on the same carbon. So this will be the 7. Or you just tell me, take 1 minute if it is possible to you, just tell me the answer. Which option will be correct? Just follow the path. Go clockwise or anti-clockwise. See, CS3, this CS3 is definitely different than these CS3s. Why? Because this is attached to the double bond and this is present on this type of a, this only carbon. So it will be 1, Here there is one hydrogen, so 2, 3, CH2, 3. Here there is one hydrogen, 4, 5, 6, and 7. So your answer must be A, 7. Okay? Yeah.
Yes, sir.
Yeah. In the next, this is like most simplest type of question. Why it is simplest type of question? You, if you, even if you don't know the answer for this, okay, H1, you just go for this like C13, because in C13 it's very easy to predict the types of carbon. Okay, so just again see whether it is symmetrical or not. Just tell me whether it is symmetrical or not.
Asymmetric.
Symmetrical or unsymmetrical? If it is
Unsymmetric.
unsymmetrical, if it is unsymmetrical now, then you will get like more than 10, more than 10 signal for H1 NMR. This is symmetrical structure. Why it is symmetrical structure? See, I will put a plane from these two. Okay, this will be like a plane. It will goes from here, then it will goes from this carbon. This is a bridgehead carbon. So this can be written like this here. Okay, CH2. I can write like this here, and the carbon, the plane will go through this bond, through this carbon, and through this bond. So it will be like a symmetrical. And when I have to count for H1 and C13, I know, or it is the rule that mutually equivalent proton, they will never couple. Hydrogens are also on the same side, bromine on the same side. That's why this is like a symmetrical structure. Now the option, see the option for carbon 444. Like 4, even if you count like carbon as an 4, you will not be, it will not giving us correct answer. So just see whether it is 4 or 7. If you think that if it is like unsymmetrical, then definitely you will get 7, but it's symmetrical. So what you have to do, see carbon, one type of carbon, two type of carbon, three type of carbon, and this is a four type of carbon. Okay, so the four different type of carbons are there. Or in another word, these two are same. These two carbons are same. So one signal. These two carbons are same. So another two, second signal. These two carbons are same. So this will be like a third signal. And this is the totally different. So this will be like a four. So you are getting this four. But now what about the H1 NMR? H1. For H1, similar type of plane will be there. One signal, second signal will be here, third signal will be here, and fourth signal of this particular hydrogen. Okay, so the 4 4 again, A, multiple choice A is correct. Now this is not like this question is there for 2 marks. Okay, this question, this type of question there, this type of question they are asking for 4 marks. Okay, is it clear? 4 4.
सो मेन्शन असतं का पेपर मध्ये किती मार्क्सचे क्वेश्चन्स आहेत?
Yeah, there no, because it is given in A, B, and C sections. So section wise it is there. No, A and B are like two marks, and C is for 4 marks.
ओके.
Yeah. Now the next, see, number of signals observed in H1 NMR of para tolualdehyde. Okay, the functional group is aldehyde. Now what I will do, I will take this structure here and I will draw its structure. Now, if you don't know the structure, you cannot predict any of this option. If you don't know, it will be like impossible to predict the this type of a structure. Now, I will give you the structure for this. Then you will realize whether it is you are getting it or not. Okay. See, this structure for this compound is like benzene ring. On the one side of benzene ring, there is a aldehyde C double bond O H. and on another side there is only methyl group. So just now tell me the answer. Number of signal observed in H1 NMR. Whether it is symmetrical or unsymmetrical. Tell me whether it is symmetrical or unsymmetrical. This compound. Come on, fast. I will take a different color pen and I will put a plane over here. See, if my axis or plane is will go from here. So what I will get like a similar type of groups on both the sides. So this is a symmetrical structure. Okay. Now what I want H1 NMR. So how many different type of protons are
Four.
there? Four. Okay. See how to calculate this. These are like all are same. Same means they are CH, okay, but they are not same. Why? Because these two, even these two are same or mutually equivalent, but these two are having a different environment. These two are having a C double bond O or aldehyde
Four
group on one
signals.
side. Yeah, this will be different. So this is like one signal. This will be two signal. This is CS3 third signal, and fourth signal is for aldehydic proton. So four signals, and this come is correct. Now again, what I am trying to say is that you should know like a this type of number of structure which are very common, which are very common. For example, just now I told you this type of structure. When you have a benzene ring, in benzene ring, if OHs, two OH, if two OHs are present on the ortho position, this compound is known as a catechol. Okay, if they are present on the meta position, that will be resorcinol, and if they are present at the para position, then it is known as a hydroquinone. Okay, this is like a very simple, and every time there is a 2 marks question they are asking. Now last question is para-xylene. Xylene, do you know xylene? What is xylene? Para-xylene. What is the structure for para-xylene? It's not that much difficult. Para-xylene, just I will draw it here. Instead of, if I remove this C double bond OH, and if I put only methyl, this is like a para-xylene structure. Okay, so what will be the answer? Para-xylene, how many signal will be there? And options will be like 1, 2, 3, and 4. Okay, tell me how many
Two.
signal H1? 2. All these are same. Okay, so this will be like one signal, and for CS3 one signal. So only two signals are there. And in the correct in the option, they are saying that one signal in H1R and two signal in H1 NMR. So you will very means it will be like sure was first will be having a C. So you have to choose that only two are correct, like B and D. Okay, so similarly, if you don't know about anything about UV, or if you don't know about anything about this IR, then also you will be very easy to predict such type of a compound. Butane is there. Butane is nothing but a alkyne, so that will give you the this type of a signal B, and you will easy now that that B section or B this B alternative is correct answer. Okay, so this type of questions they are asking every time. Give the number of signals present in H1 NMR or in C13